Now let us start. First law of motion. This is very interesting. See, this is the original science. You know that. What do you mean by science? Science is the basic law of nature. Once scientists discover this law, it is very easy for human being. Means other person said that, oh, what is new in this? Nothing is. We know it actually. But on the basis of this basic law, you can establish technology. Means the technology which we use today, this technology is based on this basic principle and basic rules and laws of nature. See, let us start the first law of motion. This is not about the chapter 8 motion. This is about laws of motion. Okay? Before starting Sir Isaac Newton, you know Sir Isaac Newton, when he was 23 years old at that time, an apple falls down from the apple tree. Okay, that's the story that you know very well. Here we are going to learn about this law. Before starting this Newton's first law, I have to say that this law, means all these three laws, they come from the Galileo's experiment. And the amazing thing is what? Do you know? Amazing thing is the death year of the Galileo is the born year or birth year of Newton, the same. And the more amazing thing is that Newton completed all the remaining task of Galileo. Whatever Galileo left over without conclusion, okay, thus all this task is completed by Newton in his era. This is a different thing. Now see, we start with Galileo. Galileo Galilei, the best scientist ever. One of the best scientists. He thought that when a ball or an object, when rolled down, what happened? Very simple question and very simple answer. But from this, the science arises. See, in this way. Suppose this is the surface and there is a plank. Okay? Suppose here we place another plank. A ball we kept here. So naturally when you kept the ball, when you place the ball, then ball roll down, it roll down and moves towards here, okay, and reaches to the top. Height from the surface to this ball when it release, this height, suppose h, and when it reaches on the second part, opposite part, then this height is also h. It means what? This height and this heights are equal. But this is possible only when this angle and this angle are equal. This is called inclination angle. So when this angle, suppose angle is denoted as theta, remember this thing, no? This is very important in maths and science. The angle is called theta. Angle is always denoted as theta. This is the Greek letter. You have learned about alpha, beta, gamma. The fourth one is theta. This is the Greek alphabet. Alpha, beta, gamma, zeta, theta, psi, xi, tau, epsilon, delta, omega, rho. Many things are there. It's okay. So angle is denoted as theta. If this angle, angle 1, and if this angle, angle 2, if theta 1 equal to theta 2, if inclination angle of both the planks are same, then you can write heights are also same, means h1 equal to h2. Means if you roll down the marble, if you roll down the ball from the top of this first plank at certain height, then it roll down and reaches to the same height on opposite plank. Okay, this is possible only when inclination angles are equal. Now see, suppose you change the second inclination angle. Now, if you change this position of the plank like this, now this is theta 3, now theta 1 is not equal to theta 3. Then what happens? When you roll down the ball from certain height, then it moves in this direction and it reaches to this position, but the heights are different because angles are different. Once again you change, means they try to decrease the inclination of second plane, suppose like this theta 4. Once again it reaches here. Maybe sometime it will happen that this ball moves in this direction and from here maybe it moves outside. Maybe possible. Okay? Same manner, suppose the inclination is 0. This angle is 0, that means theta 5 equals to 0 and this plank is on the surface. Then what happens? Then this ball roll down and move towards the surface. Up to how much distance? It covers how much distance? Answer is varied. Answer is not fixed. Why it is not fixed? Because frictional force is there. Because of the frictional force, it may be stopped after covering certain distance. You know about frictional force. Frictional force is what? The force which acting on the moving object on its opposite direction. When an object moves in this certain direction, then towards opposite direction of this moving object, a force is applied on the surface. Because of this force, it may be stopped. This force is known as frictional force. Frictional force, in short, you can say that the force acting in opposite direction of moving object. The force acting in opposite direction of moving object is called frictional force. And because of the frictional force, we are here on the earth. You can walk, you can jump, you can move in the car. The tire means frictional force is produced between tire and the surface, and that's why car or any vehicle do not skid. You can write down on the board, you can write down on the notebook. Maybe this is advantage or maybe this is disadvantage. Means for the student you can say that yes sir, it is disadvantage because suppose frictional force is not there. Suddenly from the wall frictional forces disappeared. What happened? Think about it. It's a funny answer. Okay? You can easily move heavy cupboard. You can easily move because frictional force is not there. Okay? Brakes are not applied. Everywhere, here and there will be accidents. Okay? One cannot walk. One cannot remain steady on the surface. You can imagine. Anyway, this is the different thing. Now see here once again about Galileo's experiment. Very simple. If both planks are same, means inclination is same, then ball reaches at the same height. If you decrease the inclination slowly, gradually, and it becomes to surface, that means on the 0, then this ball roll down and cover certain distance. It will stop after covering certain distance because of frictional force, the force which apply in opposite direction to the moving object. But suppose there is no force, suppose there is no frictional force, then this ball can move up to infinite distance. Exception is there. Means in the bracket, except there is no hurdle, except there is no wall like this. Means if forces are not there, then ball can roll down up to infinite distance. On the basis of this Galileo's experiment, Newton derived the first law of motion. This first law of motion is also known as law of inertia. See, it is also called law of inertia. Now the question, what do you mean by inertia? The verb is what? To inert. Inert. Inert means do not move. Inert means what? Do not move. That is called inert. Inertia. Inertia is the property of the object so that object do not move. ऐसा नहीं. So that object does not change its position. That is called inertia. The property in which object does not change its position. It means what? Suppose object is at rest, means in steady state. And if object does not move, means if object is steady, then it do not move. But if object is in motion, then it remains in its motion. This is called inertia. And the first law is the same. What is the first law of motion? If there is no unbalanced force is applied, remember balance nahi. You know that if balanced forces are applied, then body does not change its position. But if unbalanced force is not applied on the object, and steady object try to remain in steady state, moving object try to remain in motion, then this property or this law is known as law of inertia or Newton's first law of motion. Okay, see. Steady object. Try to remain in steady state. And moving object try to remain in motion until any unbalanced forces are not applied. Is it okay? As for example, at your home, suppose an object, suppose a glass of water you placed on the table. Afterwards you go outside the home, and once again after some time, after 1 hour or 2 hours, once again you come back, and if you don't see the glass of water on your table, then you judge that some force, extra force or outside force, external effect, external force is applied on it, means someone take out it. Otherwise, if no force is applied on it, then this glass of water remains as it is. Same manner your textbook, suppose it is open textbook and you are studying and suddenly someone call you, okay, your friend suppose call you, and then you stand up and move outside the home. After half an hour, once again you come back and see that there is no textbook, or the page number, we suppose you have learned page number 100 and now the page number 102. It means what? It means what? The wind force is there, and because of the wind the page changes. Means if forces are applied, if external forces, bahar se kuch force, if external forces are applied on any object, then steady object comes to motion and the moving object comes to rest or change its position. Means if no forces are applied, no unbalanced forces are applied, then steady object remains in steady state and moving object remains in motion until any unbalanced force is applied on it. Is it okay? As for example, some daily life examples are there. Take glass, empty glass, okay, and place your playing card on it, and on this playing card if you place a rupee coin, now exert the force on playing card very fast. If you exert the force on playing card, then playing card flew away and the rupee coin fall down on the inside the glass. It means what? We apply force on the playing card. If we apply force, then steady object comes to in motion, means playing card comes to in motion, so it flew away. But the steady object, according to Newton's first law of motion, the steady object try to remains in steady state until any force is applied. We applied force only on playing card, right? So a rupee coin is on it, and so we don't apply force on this rupee coin. So rupee coin remains as it is, but the base is flew away, so it fall down. Same manner, in the vacation period you play carom. If you make a stack of coins, right, and with the help of striker, if you very fast exert the force on the below or last coin, then this coin moves away, and the remaining stack remains as it is. Maybe it is possible. Once again, you can say that this is Newton's first law of motion. So everywhere, here and there, you can find Newton's first law of motion in your daily life also. More examples are there. As for example, suppose this is the important reason also, mind well and note down whatever I say. बराबर है, मैं जो कुछ भी बोलता हूँ ये रिपीट करो वीडियो और उसे नोट डाउन करो. It will ask in your exam. The first reason, suppose you are in the standing bus. Bus is in steady position, you are in the standing bus, okay, and you are also in steady position, there is no vacant seat, right? And suddenly bus start. When suddenly bus start, what happen? You lean down in backward position, backward side. Why? Think about this related with Newton's first law of motion, because Newton's first law of motion said that steady object try to remain in steady state until any unbalanced force is applied on it. Okay, so bus is in steady state. You are also in steady state, means your feet are in contact with floor of the bus and both are in steady state. Okay, now suddenly bus start, means floor try to move. When suddenly bus start, your feet are in contact with the floor, so it also start to move, but the remaining body try to remain in steady state according to first law of motion, and that's why your feet move away, means move further forward, and your body remains in steady state, and that's why you lean in backward direction. Second reason, opposite to this, suppose you are in the running bus. If you are in the running bus and suddenly driver apply brakes, means suddenly bus stop, then you lean in the forward direction. Why? Because according to Newton's first law of motion, moving object try to remain in motion. So bus is in motion, your body inside the bus is also in motion. Suddenly driver apply brakes and the bus will stop. When bus will stop, then your feet which are in contact with the floor of the bus is also become stop, but your remaining body try to remain in motion. When the remaining body try to remain in motion, then it moves, means you lean in forward direction. Okay, same manner if bus takes a sharp turn, okay, when bus takes a sharp turn, then you fall away, means in the opposite direction. Why? Think over it. Try to find out the answer, and you can find it in your textbook also, according to Newton's first law of motion. Okay, so these are the daily examples of Newton's first law of motion. And the main thing is what? Newton's first law gives us the definition of force. Now there is a definition of force. What do you mean by force? What is called force? Don't say that it is push or pull. Now on the basis of first law of motion, you can define it. Force is the external effect with which it is the external effect with which position of the object can be changed. Force is the external effect. बाहर से कुछ हम effect लगा रहे हैं. Force is the external effect such that position of the object can be changed. Means steady object comes to motion, moving object comes to rest, or its velocity increases or decreases. Means if you try to change the position of the object, then your try is called force. This is called force, which is denoted as F. And from the Newton, the unit of force is called Newton. Yeah, remember you must have to write N capital, or in short N, Newton. Now afterwards, there is a second law of motion. First, write down this, repeat this video, and write down the reason also, and check out your textbook also to find out the answer when if bus takes sharp turn, what happened. Okay?